Okay, this is problem number 33, section 2.4, and from the e-textbook. The mean value of land and buildings per acre from a sample of farms is 1800. So the mean, and this is a sample. So let me write down this information. So recall that we are going to use X bar to represent the mean of the sample. So the mean in this case is 1800. And the standard deviation is 200. We are going to use S to represent the standard deviation in a sample is 200. The data set has a bell shape, so it has a normal distribution. Use the empirical rule. Determine which of the following farms whose land and buildings values per acre are given are unusual. So it's going to be more than 2 standard deviations from the mean. Are any of the data values very unusual? So that is more than 3 standard deviations from the mean. So first of all, let's sketch the normal distribution. So it's going to be a bell shape, something like this. Okay. In the middle, in the peak, we have the mean. So the mean here is 1800. Now, more or less where the graph is bended, more or less over here, we have 1 standard deviation. Therefore, this distance from the center to this mark is 1 standard deviation, and the standard deviation is 200. So this distance is 200. So to get this value, just add 200 to 1800, and that will give me 2000. Using this distance, so we can mark another standard deviations to the right. More or less from here to here is going to be more or less the same from here to here. And so this is another standard deviation, so another 200. So 20 plus 2 is 22. So therefore here we have 2200 mark position. And now we need to add 1 more standard deviation. So this distance here more or less this distance over here. So from here to here is another 200. So 22 plus 2 is 24. So this mark belongs to 2400. We can do the same on the left. So this distance is more or less about this one, another one, and 1 more. So recall that this distance is about 200. This one is about another 200. And this one is about another 200. So just subtract 200 to 1800 to get the marks over here. So 18 minus 2 is 1600. 16 minus 2 is 1400. And 14 minus 2 is 1200. Okay, now we need to identify, let's play these numbers there. More than 2 standard deviations, they are unusual. 1, 2, so from here on the right and 1, 2 standard deviations to the left. So if a value falls in this region over here or in this region over here, they are called unusual. Now, very, very unusual is about 3 standard deviations from the mean, 3 to the right and 3 to the left. So in that case, it's going to be from here all the way to the right, or this, remember, is 3 standard deviations, so from the center is 1, 2, 3, from here to the left. So this is very unusual. Here is very unusual. And here is just unusual. Now let's play these values. The first question is, which of the farms are unusual? So 2012 is not more than 2,200. So this is not unusual. 1,752? No. 2,378? Well, 2,300 is more than 2,200. So this is going to be unusual. 1,681? 1,681 is going to be over here. No, that is not unusual. 1,667 is over here. No. And 1,038 is going to be less than 1,200. So it's going to be over here. Actually, that is very unusual. I don't know if here is just, well, unusual is from here to the left, so this is included in that range. So unusuals are going to be C and F. Let me answer this question. C and F, both are unusual. And now it's asking which one is very unusual. The one that is very unusual is this one, the 1038. Is on the left on the green region. If you remember, is this value falls over here, which is to the left of this green region. They are very unusual. So it's when it's 3 standard deviations out from the mean. So that is the only one. So that one, and check the answer. And this completes the problem.